Break-even analysis is an important application in business. The level of production in which a company neither makes a profit nor a loss is what is referred to as the break-even level. The break-even can be determined by finding the point of intersection of the revenue and the total cost functions. All right, so in other words, this break-even point, right? This is where there's no loss, there's no profit. That's where the revenue is equal to the cost. Take a look at the graph that I have over here. This line is the cost function. This line is the revenue function. Now, and this X axis represents the production level, right? We're producing X number of units. And so as long as the number of units that I have is in this region here to the left of my break-even point, I'm going to have a loss because my cost exceeds the revenue. The cost function is higher than the revenue, so I'm going to have a loss in this region here. And certainly I don't want to have a low level of production that would give me a loss. In this region here, this is where I have a profit. This is where my revenue function is higher than my cost function, right? So my revenue is higher than the cost, and the difference between revenue and cost is my profit. Where these two lines intersect, where the revenue function line and the cost function line intersect, that's what we're calling this break-even point. The X value of this break-even point is the break-even quantity, right? How many units should be produced and sold in order to reach a break-even? And the Y is the break-even revenue, right? How much do I have to receive in sales, right? What should my revenue be in order to reach that break-even point? All right, so we can take a look at an example for using this break-even analysis. So in our example, we have a division of Carter Enterprises that produces income tax apps for smartphones. Each income tax app sells for $8, and the monthly fixed cost incurred are $25,000, and the variable cost of producing each app is $3. And the first question that we're trying to determine is to find the break-even point for the division. In other words, I'm trying to find this point here. I'm trying to find where the revenue is equal to the cost. So the first thing that I would need to do is to find the cost function. Okay, so the cost function, how much does it cost for each app to be produced? That's $3. That's the variable cost. Right, so that's 3 times X, where X is the number of apps produced. And we have also a fixed cost. Even if we were to produce 0 apps, our fixed cost is still $25,000. Right, so our cost function is 3X plus $25,000. I also need to find the revenue function. The revenue function is how much I will bring in from selling these apps. And each app sells for $8, so the revenue function would be simply 8X. I would get $8 times the X number of apps that are sold. So now the break-even point. This is where the revenue function equals the cost function. So I'm going to take these two functions and set them equal to each other. Revenue equals cost. And solve for X. We can solve for X by subtracting 3X from both sides. 8X minus 3X is 5X. And divide both sides by 5. 25,000 divided by 5 is 5,000. This is my break-even quantity. These are the number of apps that must be sold to reach a break-even, to where I won't have a loss, but I won't have a profit. Right, and this break-even point, right, break-even quantity, right, this is the minimum I would need to make to prevent having a loss. Of course, I don't want to to reach a break even. I want to be above a break even so I can realize a profit. That's my break even quantity, right? I'm trying to find the break even point. So I need an X and a Y value. So to find the Y value, we can take this 5,000, we can substitute it into either equation, right? Because we forced these two equations to be equal to each other. So the Y value should be the same in both of these functions when X equals 5,000. So I'm going to use the easier one, right? This revenue function. That'll be easier to evaluate. So when X is equal to 5,000, what's the revenue? The revenue should be 8 times the 5,000, which is 40,000. Right, so I would have to reach $40,000 in sales to reach that break-even level. Okay. Now I do want to have a profit, so that's the question number 2. What should the level of sales be in order for the division to realize a 15% profit over the cost of making apps? Right. So I want my profit to be 15% over the cost. Right. So in other words, I want 15% over the cost function, 3x plus $25,000. And I want this to be my profit, right? I want the 15% times the cost to be equal to the profit. So I also need a profit function. And we've said that the profit is the revenue minus the cost, right? So I want this to be equal to the revenue minus the cost. Okay, so now let's see if we can simplify this to arrive at the sales level that we need to reach that 15% profit. So on the left-hand side, 0.15 times 3x plus 25,000. 0.15 times 3x is 0.45x. 0.15 times 25,000 is 3,750. On the right-hand side, don't forget to distribute your minus sign. That's 8x minus 3x, which is 5x, and minus 25,000. And I'll mention that this is the profit function. 5x minus 25,000 is the profit function. And so now we're solving for x. I'm going to solve for x by subtracting the 0.45x from both sides. Yes, I could have subtracted 5x from both sides also. It doesn't matter which side the x is on. I'm subtracting the 0.45x from both sides just because I like to keep the x term positive. So I'm keeping the x on the right-hand side, so that way it's positive. And so if I move the x term on the right-hand side, I'm going to move the constant term to the left-hand side by adding 25,000 to both sides. This leaves me with, let's see, 25,000 plus 3,750 is 28,750, and that's equal to 5x minus 0.45x, which is 4.55x. And then finally, we'll divide both sides by 4.55. And this will give us the production level that I need to reach the profit that I want to obtain. 28,750 divided by 4.55 is 6,318.68. Now we're talking about the production level. How many apps must we sell? So we'll need to round that to the next number. 6,319 is the number of apps that we need to sell in order to realize a 15% profit over the cost. And for the last example, I want to go back to the previous video that we had when we were talking about the truck leasing company, right? We were leasing a truck and we were trying to determine which company to go with. We were only driving 30 miles. Let's revisit this example. So to summarize that example that we had, we said that the Ace Truck Leasing Company had this linear model for how much it cost to rent a truck for one day. That was 0.5x plus 25 $25 per day to rent plus 50 cents per mile. Acme Truck was 60 cents per mile and $20 a day. And in our example, we were planning to drive it at most 30 miles. And so the Acme Truck company was more cost effective. It was $38 compared to the Ace Truck being $40. Right? But at how many miles will the Ace Truck and Acme Truck lease cost the same? Right? And we can use this break-even analysis to where, when will these two functions be the same dollar amount for the lease? We can do this by setting the functions equal to each other. 0.5x plus 25 equals 0.6x plus 20. We're forcing them to be equal by setting them equal to each other, by setting the functions equal to each other, and solving for x will tell us how many miles that we drive, which results in the break-even point. All right, so subtract 0.6x from both sides. Again, it doesn't really matter which side you move the x to. 0.5x minus 0.6x is negative 0.1x. And I'll at the same time subtract the 25 from both sides. 20 minus 25 is negative 5. And here I said in the last example, I like to get the x terms on whatever side results in a positive number, just because we don't need to work with a negative. Here I put the x on the left-hand side, and just to show you, it's not any more difficult to work with negatives, but maybe you prefer avoiding working with negatives. And in that case, you want to use my strategy that I had in the previous example. But either way, divide both sides by negative 0.1. Negative 5 divided by negative 0.1 is 50. Right? This is the break-even point, the break-even quantity. This tells us that if we were to drive 50 miles, then the Ace Truck and the Acme Truck would cost the same amount. If we were to drive less than 50 miles, then the Acme Truck would be better economically. If we plan on driving more than 50 miles, then we would want to lease our truck from the Ace Truck Company.